quite often when you record rotations, the resulting animation doesn't match what you did in the viewport. And I'm going to show you the reason for that and also the solutions as well. So let's create an object whose rotations are going to be clearly visible. So we'll go to the Edit menu, under Preferences, under Add-ons, we'll search for Bolt, so B-O-L-T, and then we're going to enable the Bolt Factory add-on. And this is going to give us bolts available in the View 3D Add menu under the Mesh submenu. So Shift-A, go to the Mesh menu, and at the bottom we've got the new Bolt option. So click that, and then you can change the parameters of the bolt either in the Redo menu over here, or what I prefer to do is press the F9 key, and then we can get more space to see it. So I'm going to change maybe the shank length a little bit, and then we can start recording some animations. So we'll just reduce the timeline to maybe 150. We'll select the bolt, and what I want to do is add a keyframe for the rotation on the first frame. So make sure in the first frame, shift left arrow, we'll bring up the Insert Keyframe menu, and we'll choose to add rotation keyframes. Now we'll go to the last frame, shift right arrow, and we're going to rotate this on the Z-axis. If we just bring up the gizmos, we can see that. So rotation gizmo, set to local. Now RZ, and I'll say 360. Insert keyframe menu, and we'll choose rotation. Now if I play this back, everything's going to work as expected. So let's copy this now to demonstrate one of the potential problems you're going to run into. So Shift-D, we'll move it across on the Y-axis. We'll just delete these keyframes now, A, X. I'm going to start with the object rotated at 45 degrees on the X-axis. So R, X, we'll say -45. And now we'll add a keyframe to the first frame. So I, and add keyframe for rotation. We go to the last frame, and I want to rotate it again around the Z-axis. So RZ 360. And then we'll press I, rotation. And if we play this back, you can see we're now getting an unexpected result. It's no longer rotating around its own local Z-axis. And the reason for this is that keyframes aren't created based on the local transform orientation. They're actually recorded based on the parent space. So because this bolt doesn't have a parent, that's going to be the world. So if we just change this to world, we can see what's happening. It's rotating in this way around the Z-axis here. So play that back, and you can see it's rotating around the Z-axis of the world. So how do we rectify this problem? Well, there's two ways we can do it. So let's just copy this one, Shift-D, move it across a bit further past. So the first way is, because it's going to be creating keyframes based on its parent, we can give this a parent and then rotate the parent first. So let's Shift-S, and we'll say cursor to selected. So we've got a 3D cursor at the bolt's origin. And now when we add an empty, we'll just scale it up a bit. We can parent the bolt to the empty, Control P. And now we choose the empty, we can rotate that on the X-axis by -45. And now when we play it back, it's going to work as expected, because the bolt is using the parent space, which is the empty, which we've rotated, so it's still lined up correctly with the bolt's orientation. The next way we can fix this without using a parent, so let's copy it again, Shift-D, move it across on the Y-axis. We can use the objects. If we go to the object panel, we've got two sets of transforms. We've got the transforms that we've just keyframed. We've also got delta transforms, which are additional transformations which happen on top of the ones we've done here. So if I rotate this by -45 on the X-axis under the delta transform, and then play it back, that's also going to work as well. So they're the solutions to the first issue. Let's now have a look at a second problem that you're likely to run into. So starting again with a fresh bolt with no keyframes on it, and make sure these rotation values are back to 0. We're going to do a different animation this time. We're going to rotate it on 2 axes to demonstrate the next problem. So on frame 1, we're going to press I and insert a rotation keyframe. We'll go to the end keyframe, the end frame, and now we're going to rotate it on the Z by 360. Press I, rotation, and now we're going to rotate it on the X by -45. So RX, -45. Press I, rotation. We don't want this one here. We'll just get rid of that. Right click, and we'll say clear single keyframe. So we don't want that. Right, let's play this back. What I'm expecting to happen is that it's going to rotate this way, and as it goes, it's going to be rotating around the Z-axis. But this is what's actually going to happen. And this is because it rotates these axes in a specific order that we specify over here. So we're using Euler rotations, and at the moment it's using X, Y, Z. And that means it's going to be rotating the Z, then the Y, and then the X. And if you want to see what happens, let's play this back. We'll change it to gimbal orientation, so this gizmo shows us what's actually happening under the hood. So if I play back, you'll see it's rotating the Z, but as it's rotating the Z, because the Z is the parent, the location of the X is being rotated by the Z-axis, and then the X is being rotated because it's going Z, Y, X. Y is a child of Z, X is a child of Y. So this is the problem. It's rotating on the Z and then the X. Right. What we need to do is tell it a different order. So we want it to rotate on the X and then have the Z come along with the X instead. So let's change this over here so that the X is rotated first, and now the Z is going to come along because the Z will be a child of the Y and the Y will be a child of the X. So let's have a look at how this works. We play this one back, and now you'll see it's rotating the X first, and because of that, its children, the Y and the Z, are coming along for the ride, and that means the Z is going to be correctly orientated to get the result that we expect. So that's why it's important that you choose the correct order of operation. So starting with a fresh bolt, no keyframes and no rotation set, we'll add a rotation keyframe to the first frame, so I, and then rotation. And then we're going to go to the last frame, we'll do RZ 360. Let's just change it over here. It seems to have added 0.001. So 360, right click and say insert a single keyframe. So now we've got the desired result, steady spin around all the way to the last frame. On frame 75, I want the bolt to rotate this way by 90 degrees. So do RY 90, add a keyframe. And then on the final frame, so let's go to the last frame, I want to rotate it round this way by 90 degrees, -90. We'll press I, rotation. Now, let's play this back and see what happens. I'm expecting it to go down this way and then come round at a 90-degree angle this way. So play it back. All looking good so far. But then as soon as we get to the halfway point and it starts coming towards its final destination, it's taking a very strange route. And the reason for this is if we look at the gimbal, so we can see what's actually happening in the rotation system, as soon as we get to the center, we're losing one axis because the Z and the X are now aligned due to us rotating this middle axis over here because the Z is a child of the Y. So we need to find a way to avoid that happening because at this point, there is no axis in order for the bolt to come around this way. You can see we've only got two axes essentially. So what we need to do is not animate that central axis so that we don't end up in this gimbal lock position where we've lost one of the axes. So let's just delete the Y keyframes, right click over here, and we'll say clear single keyframes. And we're going to get this result now. So that's now working as we expect. So instead of rotating the central axis over here, I'm going to use a parent to rotate just that one axis. So let's put the 3D cursor back to the origin of the bolt. So Shift S, cursor to selected, Shift A, add an empty, go with arrows, scale it up a bit. And I'm going to parent the bolt to the empty, Control P, parent to the object. I'm going to select the empty, and we're going to add a keyframe on frame 1 for the rotation. And then on frame 75, I'm going to rotate it this way, so 90 degrees, press I, rotation. Now if we choose the bolt again, and we've still got the gimbal selected, go back to frame 1, you can see now that the axes are no longer getting that gimbal lock problem because the bolt itself has no rotation values on the y-axis, so the z-axis isn't being brought in line with the x. And that's resolved that issue. And again, if you wanted to start off with a starting position, we can add another empty to be the parent of the existing empty, just like we did in the first example. Let me just move these around and rename them so it's a bit more clear what they do. And now we'll create another empty. So Shift D to copy this one. And now I'm going to parent the Y rotation empty to this one. Control P, object, and now using this one, so let's just rename this to initial rotation. We can rotate that wherever we want, making sure I delete the keyframes from the second empty. And now play it back, and everything's going to work correctly. An alternative way of doing it, without using two parents, is to, let's just get rid of these empties, X, delete. Now we've got the bolt on its own with no parent. We can use the delta transforms again. So on frame 1, we'll go to the delta transforms of the bolt, and I'll add a keyframe for the rotation. And then on frame 75, we'll just change this to 90 degrees and add another keyframe. Now if we play this back, we're going to get exactly the same result because we're not rotating the Y with the main rotations, we're doing that with the delta transforms afterwards. And again, if you want to start from a different rotation, initial rotation, other than the world, Shift A, add an empty, scale it up, and then we can parent the bolt to the empty, and then we can rotate that empty wherever we want, and we're going to get the same result, because now the bolt obviously is getting its transform orientation from the empty rather than the world. Now, beside the Euler rotation mode, we've also got a rotation mode called quaternion, and this will try to find the shortest route to the intended end rotation, and it avoids all the problems we had with Euler, like gimbal lock. It does have a limitation though, it can only rotate one full revolution, and that makes it most suitable for things like limbs that can only generally move within that range. So I've included this file, quaternion rotations, that you can open up. It's in the Animating chapter, Animating Rotations subfolder. So open that up, click on the armature, and don't worry too much about armatures at the moment. This is why I've provided the file, because we've not yet covered it. We are going to cover armatures in depth later on in the course. So once you've selected the armature, to animate the bones, we'll press Tab, and we need to go into pose mode. So this is where you can animate the bones. And we'll select this upper arm. And on the first frame, press I, and we'll animate the rotation. So we've got the initial keyframe. Let's go to frame 60, and we'll look at a problem that you might run into. So I'm going to rotate the bone from here to here, and I'll press I and record the rotation, and that's going to be fine. It's going to go the shortest route. So let's just get rid of this keyframe on frame 60. And this time I'm going to rotate all the way around to here. So I'll press I, record the rotation, and now it's going to take the shortest route, but we wanted it to take this path. So this is the problem that you might run into with quaternions. And to avoid this, there's two ways you can do it. So the first way is after you've done it and you spot the problem, you can go to that keyframe, making sure you're in pose mode. This will only work in pose mode, with the bone selected, with the timeline on the keyframe that you want to amend, and press Alt F. This is going to update the values over here, and then you can hover over it and press I. And now when we play it back, it's going to go the way that I intended. The second way you can do this to avoid the problem in the first place, if we just go to frame 60, I'll delete this keyframe again, is to rotate it a little bit, and this is going to update the values over here. And even though we don't add a keyframe, if I now continue rotating in a second movement, and then press I to add the keyframe. Because if we did it in 2 movements, and after the first movement these had changed from the original values, it will now go in the way we intended. So that's the second way you can avoid that problem. So bear that in mind later on in the course when we start animating our robot.